You don't know.
No promises.
Watch your profanity.
Alright, so this is a non-calculator free response. And this is very similar to the last lessons that we covered last week regarding continuity and differentiability. So let's kind of go through them, okay? The first one says if A is equal to -3 and B is equal to 4, will f of x be continuous at x equals 2? So before I get started on this one, I might want to replace A and B with what they want me to, right? So I'm going to say f of x is now going to be equal to what?
-3x squared plus
Negative 3x
4x.
squared plus 4x plus 2. And that's going to be specifically when x is less than or equal to 2. What is the second equation going to be?
-3x plus 4.
Negative 3x plus 4, and that's going to be when x is more than 2. Alright, so now we have the exact equation they want me to work with to prove that it's continuous at 2, specifically when those A and that A and that B are those specific numbers. So what's the first thing to prove for continuity?
F is defined.
That it's defined specifically at that point 2. So can I find f of 2?
Yes.
Which equation would I plug that into?
The top one.
Right, so show me -3 times 2 squared plus 4 times 2 plus 2. This is non-calculator. 2 squared, that's 4, right? We don't do this times this, which is what some of you do. Be careful. Exponents first. 4 times -3.
-12.
-12 plus
8.
8, so that's -4 plus 2.
-2.
2. The second step is to show that the limit of the function from the left of 2 is equal to the limit of the function from the right of 2. So, did I already do one of those limits
Yes.
by doing step 1?
Mhm.
Yeah, right? When I plug in 2 in there, that's like getting this limit, and we ended up with -2. What would I get when I plug in 2 to the other one?
-10.
-6.
No, wait, you get to
Plus
-4.
4.
-6 plus 4, right? Is
2.
-2 as well?
Yes.
So did that work?
Yes.
And the third thing to show is that the function value f of 2
Equals the limit.
is equal to the limit value.
Therefore.
Is that really actually necessary?
And are they equal to each other?
Yes.
Yes. So therefore we can say
F
f of x is continuous at x equals 2, specifically when a equals -3 and b equals what? Too easy?
Yeah.
Yeah? I know.
Wait, yo.
I just brought it today, yeah, because I wanted, some kids were gonna be out and they we're gonna hear the full lecture. Alright, can we move on to B?
Yes.
B wants to know if A is -3 and B is 4, so we're still working with this equation. Will F be differentiable at 2? Okay, so remember, for something to be differentiable, it must first be what? Is it
Continuous.
continuous when these guys are these numbers?
Yes.
Alright, so let's say that. Just write it down. Okay, so we can say f of x is continuous at x equals 2 when a equals -3 and b equals 4. I'm just going to put shown above. If I hadn't done part A, then on this question I would have to do part A plus the second step of part B. Does that make sense? So the second step, in order to prove that it is differentiable at 2, is that I have to show that the limit of the derivative as x approaches 2 from the left is equal to the limit of the derivative as x approaches 2 from the right. So, in order to do this, I need my derivative equation, right? What would be my derivative equation when a is -3 and b is 4?
-6x plus 4.
-6x plus 4? On the bottom? Negative. Am I going too fast?
No.
Because I already know what I'm going to write. You're waiting, right? For me to write, to know what I write? Whatever that means. So, let's check these two limits and see if they are equal, okay? What would be the limit from the left of 2 for this derivative?
-8.
So that'll be -6, right? No, -12, right? Plus 4? -8, and the limit from the right?
-3.
So are those equivalent?
No.
No, so we could say that f of x is
Not differentiable.
Not differentiable.
X equals 2
at x equals 2
when A equals -4.
when a equals -3 and b equals 4 because
The limit of the derivative as x approaches 2 from the left is not equal to 1 from the right.
you could just say the limit of the derivative as x approaches 2 does not exist. Would that be okay to say that? Yes? Does this limit exist here? No, because the limit from the left does not equal the limit from the right. So that's more than enough. That's a little bit shorter than having to write both of them and put not equal.
Right.
You could write the other one. Just giving you options. Be careful, make sure you put the prime there, okay? If you don't put the prime, you're not gonna get the credit for that. You're telling me a different
Next this
statement.
one, my answers are right.
Good? Alright, and the last one, and we'll be done with the review, okay, is this last one. It says, for what values of A and B, so now I have to find the A and the B that will make f be both continuous and differentiable at 2. So this is like the examples that we did on the notes. So you gotta kind of split it up, right?
Yeah.
And do 2 things. You gotta say if f of x is continuous at x equals 2, then what 2 limits must be equal?
The limit from the left and
The
the
limit as x approaches 2 from the left must equal the limit as x approaches 2 from the right. But now we don't have the specific A and B that we need. We're gonna make a formula to find the A and the B. Okay? So what are we gonna replace in the original equation at the top?
You're gonna
We're gonna
x
replace
with
the x's with a what?
2.
With a 2, and we're not gonna touch A and B. Does that make sense? So you're gonna put a 2 for the limit for the left in here. So 2 squared, that's what? 4. So we're gonna get 4a plus 2b plus
2.
2. So that's what this limit's gonna be, 4a plus 2b plus 2. That's gonna equal the limit from the right of 2, which is where you're gonna put 2 in for x in this equation. So that's gonna give me what? 2a plus b. And we already know that eventually in this problem, we're gonna have to come up with a system, right? So let's put it in a form that I'm gonna be able to work with it. So let's put it in standard form. So let's minus the 2a and then minus the b,
And then minus the
right? And then we're gonna minus the 2, so we're gonna move it over here. Yes? So what do we end up with? What's 4 take away 2?
2a plus
2a plus b equals?
b.
I already have it set up in the proper relationship to make it easier for me to work. Good? That's the relationship between A and B that has to exist in order for it to be continuous. You can pick whatever A and whatever B you want that satisfies this, and then we could be able to say that that function would then be continuous. So if we picked -3 and 4, does it satisfy this? What's -3 times 2? -6 plus 4? Did it equal -2? So that's why when we picked a -3 and 4 up here, we said that it was continuous. Does that make sense? If you can think of any other numbers that would satisfy this, then we could also say that it would be continuous when A and B are those numbers. Make sense? Alright, second thing is if f of x is differentiable at x equals 2, then what 2 limits have to be? The limit of the derivative as x approaches 2 from the left has to equal the limit of the derivative as x approaches 2 from the right. do we have the derivative of the original one, the one at the very top? No, we have the derivative of the one that we plugged in numbers for, right? So let's come back up here and let's get the derivative. What's the derivative of the top thing?
2ax plus
2ax plus b, okay, and the bottom one?
A.
A, right? Okay, cool. So now we're gonna plug in a 2 into the top one and a 2 into the bottom one for what letter?
X.
X, okay? So put a 2 here, we get 2 times 2. So we get 4a plus what?
B
Plus b for the limit from the left.
equals
And on the right side, there's nowhere to put a 2, so we just end up with
A.
Be careful, okay? I know some of you are gonna put a 2, and you're gonna put it in place of the letter A. That's why I keep stressing, the 2 takes the place of X. You're gonna mess up, so be careful. Yeah?
Yes.
Right, so how could I fix this one?
Bring the A to the other side.
Minus the A, so now I have 3A
Plus B.
plus B equals what?
0.
So now I have 2 equations with the same 2 variables, and both of them are needed to satisfy the other. This has to be true in order for this to be true. So I can use them together, and I can solve the system. Okay, so the system will be 2a plus b equals -2, and the other one is 3a plus b equals 0. How can I solve this system?
Cancel the b's.
Negative
Multiply
to the
one
top.
of them by -1, so we can eliminate which variable?
The b.
B, okay. So we would end up with -2a minus b equals 2.
Minus b. The b's cancel out.
B's
Wait, sorry, I'm
cancel
sorry,
out.
you were rewriting it.
So now we can combine them.
Yeah.
So 3 take away 2.
1.
1a
A
is equal
equals
to
2.
2. All right. Now we need the b. What's the b gonna be? Which one do you want to use?
The 3A plus B.
Top.
So 2 times 2 plus b equals -2.
Yeah.
2 times 2 is 4. Take away 4, right? So b has to be?
-6.
We find the a and the b that will not only make it continuous, but also make it
Different.
Yes,
differential.
we did.
So if I put a 2 and a -6 here, it'll satisfy that. And if I put a 2 and a -6 there, it'll satisfy that. Therefore, it will guarantee that both things are wrong. That make sense? Pretty simple?
Yeah.
Okay, there will be a problem like this, okay, and there will be a problem like this one. You need to be able to also do what we did here. Any questions on that second free response?